So this test has been used in Rogers Pass since the beginning of the program, and it lets us identify weak layers in the upper portion of the snowpack. We have 9 telemetry stations situated around Glacier National Park at various elevations and locations, both east through west. And they give us a remote opportunity to monitor the weather, snowpack, and avalanche conditions. We're looking at how the snow is formed. We're looking at all the factors that result in the snow ending up on the ground. And then we are interested in the distribution of the snow, so where the snow is based on elevation, aspect, slope angle for where and how avalanches form. We get an idea of whether the types of avalanche control methods we use would be effective in controlling the snow. So by control, I mean starting an avalanche that is effective in moving snow out of a start zone and mitigating the risk for the highway and increasing the safety for the traveling public.
Over the past several years, there's been tens of millions invested to improve the safety of the corridor and mitigate against avalanche hazards. In our investments, we've got both static defenses that either protect the highway, stopping the avalanches, or containing them, like the snow nets, which retain the snow up at elevation, and as well a stopping dam at one of the more unpredictable sites. We also have active avalanche controls installations, including avalanche control towers on 3 different mountains. Also in our suite of investments was a one-of-a-kind avalanche detection network. The avalanche detection network is a system of infrasound detection as well as radar that both senses when avalanches occur and can actually send messages to the avalanche control section to their phone. It gives them real-time data that influences their decisions on controls on a day-to-day basis. What we learned from is both our peers locally with the Ministry of Transportation, for example, our own avalanche control section. In addition, we look to other industry leaders, oftentimes in Europe, whether it's Switzerland or Austria, and learn from state-of-the-art technologies.
So every year, the snowpack forms differently based on different weather conditions, different snowpack conditions, how spring turns around, and then in part that turns into different avalanche problems throughout the year. So it's different every year.